So in the last video, I told you to call someone stupid. Now that's not nice, so don't do that. Just call them ignorant and they don't know what they're talking about. Okay, so now the next topic is the oxygen deficiency and oxygen debt. Now this is the most confusing topic for students, mostly because it's explained horribly. But it's one of the most confusing topics, but it's very simple actually. And one of the basis behind this, the science, is actually used in like the workout insanity and high intensity interval training, which are very effective. But so oxygen deficiency and oxygen debt. Deficiency, debt. Now, in order to understand this, I'll go into again make another metaphor in relation to money. It seems everything is going to money that I'm talking about. But it's very easy to see that because everyone can relate to money and whatnot. But essentially, oxygen deficiency and oxygen debt is okay. So you have your graph. Now, for oxygen deficiency, we're going to first talk about oxygen deficiency because that's the very first step. Oxygen deficiency, think of it's essentially what it's saying. You're deficient of oxygen. You don't have enough oxygen in order to complete the activity that you're asking your body to do, or the exercise you're asking your body to do. So an easy way to think about it is, say everyone is at a base level of oxygen at rest. So you're resting. I'm resting right now. I'm just sitting here talking, sitting in my chair. So I'm using a certain amount of oxygen, or my body's using a certain amount of oxygen to run all my metabolic pathways, to run glycolysis, to keep my heart beating, whatever it's doing. So it's using a set amount of oxygen to keep my body running. Let's call this set amount of oxygen 5. The hell of it. So I'm using 5 liters of oxygen to keep my body running. Now say I just stand up out of nowhere, because I don't know, I just stand up out of nowhere and I sprint out of my hotel room. So the act of sprinting obviously requires a lot more oxygen than it takes when I'm just resting. So now say I require 50 liters of oxygen. So much more oxygen. And because the activity is so intense, I require the oxygen much faster and much, everything relates to how fast you need energy, how intense it is. But say the exercise is very intense, I need the energy extremely fast. So I have to very quickly get from 5 liters of oxygen to 50 liters of oxygen very, very quickly. Now, in order to do this, obviously you can tell 5 does not equal 50. I have a deficiency. There's a huge deficiency. So in order to get this huge deficiency, my body has to do quite a few things. It has to first increase its body temperature, increase my heart rate. I have to breathe more. My muscles have to increase contraction. I have to increase my production of lactic acid, blah, blah, blah. My blood flow to my muscles. I have to do all this shit, all these physiological things that you don't need to know. But I have to do a lot of things in order to increase that, to bridge the gap between that deficiency. So say it takes this long. I have this little graph. Now the slope of this peak, this relates to how intense the exercise is. If the slope was like this, then the exercise was extremely intense, and I got the oxygen extremely fast. If the slope is like this is usually used if it's a long duration exercise or slow intensity, or low intensity. You don't need the energy right away. This will be aerobic respiration. This will be anaerobic respiration. This is also anaerobic respiration. I just drew it closer for some reason. So you have this. Now the way that I relate this to money and the way I teach it is also my study guide is, say your set level of oxygen, I'll use the numbers I use in the study guide, was $25. So say you have $25 and you need $100 of oxygen, make it up units here, but you need $100 of oxygen in order to do that activity, which is sprinting or whatever it is. So you have this deficiency of $75. So you essentially, for rough metaphors, you borrow $75 of oxygen from your body. This will be increasing your heart rate, whatever, doing all these things. So you borrow that oxygen or that money. So now you're at this thing. This is called steady state. Don't know if she'll explain that. But essentially, steady state's a very simple term. Steady state means you're working out at the right intensity, or your body, your metabolism, I guess, is at the right intensity where you can maintain that intensity for, I won't say a long duration, but you can maintain that intensity. It's not requiring more energy or it's not requiring less energy. You have just the amount of energy. It's steady state. You're in a steady state. You're just chilling, just relaxing. So you borrow that oxygen. This is called oxygen deficiency. this whole first process. And now what happens when you stop exercising? So now you stop exercising. What's going to happen? Well, when you stop exercising, you're not going to be on $100, quote unquote, of oxygen anymore because you don't require that much oxygen because you're not working out anymore. But so you will be back in 25 because you're resting. But like what we talked about in active recovery and passive recovery, you know, if I just stood up out of nowhere and sprinted across the street, if I just stopped running all of a sudden, 1 second after I stopped running, I'm not going to be back at the same level that I was when I first started running, or when I was sitting in this seat. Everyone knows that because your body, your heart is increased, you're panting more, your body temperature is raised, you're recovering from exercise. So this recovery period takes a while to recover to get back down to your resting level. Everyone knows that. So, and ironically, or not ironically, I guess, but once you know that the curve that it requires you to get back down to resting level, that this picture doesn't show to scale at all, but that curve that requires you to get back down to resting level is actually the same exact slope that it is to get up to steady state. So get to steady state, go back down, the curve is just as long, or I'm going to say it's just as long. It takes you it may not take you just as long to recover, but metabolically inside your body it takes that long to recover. And this means during this curve is when you're decreasing your body temperature, or you're decreasing your body temperature. This is when you're recycling lactic acid in the Cori cycle. You're decreasing the amount of enzymes you have, or hormones you have in your body. Don't worry about that, but you're doing all these things to decrease your or to bring your body back to homeostasis, to like slow your heart rate down, slow your respiration. So this is called oxygen debt. You're in debt because you borrowed $75 of oxygen, so you had to make up that debt by doing these things in order to get back down to $25. I don't know if that metaphor at all makes sense at all, but that's pretty much it. So you have your graph. This is duration or time. This is intensity. Nah, I wouldn't say that. Oxygen, oxygen deficiency, oxygen debt. First, you have an oxygen deficiency. So this is the deficiency. And then you stop exercising, and then you have a debt to repay of oxygen. And during that debt, you're recycling lactic acid to the liver, you're decreasing your body temperature, you're decreasing your heart rate, you're decreasing your hormone level, your body's getting back to homeostasis. And during this whole process of oxygen debt, your metabolism is greatly elevated. Metabolism, that means you're burning more fat, you're burning more fuel, and all that stuff. So your metabolism is elevated because metabolism has to be elevated because it has to recycle all that lactic acid and whatnot. So your metabolism is elevated. Now, some questions that they can ask, I don't know if she'll go over it, but Dr. Moffat went over it, is the more intense the activity is, we talked about the greater the slope is. So your oxygen deficiency is kind of greater. Now something else they ask is with training, well, actually we'll talk about it in another video, but now let's look at the oxygen debt when you stop exercising. This line is the cessation of exercise. You stop exercising. Now, Dr. Moffat breaks it down to 2 phases of oxygen debt. I don't know if she will, where the first phase is called the lactate portion, and the second phase is called the alactate portion. Very simple. You can tell by what the name says. You have the lactate portion and the alactate. Now, if you don't, say you forgot what these terms are called, you can't Google these terms and look them up in a book. These are not real terms. They don't exist. If you Google them, or if you look them up in an exercise physiology book or a PubMed peer-reviewed article, these words don't exist. Lactate and alactate. They're not real words. They're just made up by some random exercise physiologist who wanted to explain different steps of the oxygen debt cycle slope. The first slope is called the lactate. That's the whole process of when you're metabolizing lactate to the Cori cycle. The second stage, the lactate, is when you're decreasing your heart rate, you're decreasing respiration, you're decreasing hormones. So lactate always happens first, and then the alactate, because places like 30 minutes after you exercise, you're not really metabolizing lactic acid anymore. Most of that was gone already if you did a past active recovery, but the metabolism is greatly elevated. Now, Insanity takes advantage of this. Now, let's just go throw something in here so you can use to your own advantage to train to fat loss and whatnot. The high intensity interval training is one of the best ways to lose fat and build muscle and get a six pack and whatnot. And I talk about this a lot more in the third exam, but I'll talk about it here because it takes advantage of the oxygen debt and oxygen deficiency and oxygen debt graph. This is what Insanity is based on and why Insanity is so insanely effective. So, as you know, the greater intensity, the greater the oxygen deficiency. So say it's really high intensity, you have this deficiency, you stop exercising. When you stop exercising, you start going into recovery mode. But then you immediately start exercising again. That's not really a good graph to draw because I didn't really draw it that good. High intensity, stop exercising, you start recovering. Really, you burst into high intensity again, you stop, you recover. High intensity, stop, recover. High intensity, stop, recover. High intensity. As you see, this graph keeps going up. The recovery is not long enough to decrease your heart rate all the way back to resting value. But the whole point of this is, remember, when you stop exercising with oxygen deficiency, you're increasing your metabolism. The greater intensity the exercise is, the greater this effect is, this increased metabolism. And thus, this is why Insanity is so effective, or really high intensity interval training, where you do an intense activity for like 30 seconds or a short period, you rest, you let your heart recover kind of, and then you burst back into doing this high intensity exercise, let it recover a little bit, high intensity exercise, let it recover, high intensity. Each time you do this high intensity bout, you get a higher on this oxygen deficiency level, and then when you finally stop exercising, your oxygen debt is so great that it takes a while for you to recover. Now, physically, you may recover in like an hour or so, but physiologically inside your body doesn't recover for like 5+ hours after you stop exercising. And during all that time, your metabolism is increased. This process is called, if she talks about it, is called EPOC, or excess post-oxygen consumption. It's when your metabolism is greatly elevated after you're done exercising because of oxygen debt in the lactate and lactate push, whatever. But this is whole oxygen deficiency, oxygen debt. Hopefully you understand it now. But let me look into the guide right now and see if there's anything that I am missing about oxygen deficiency and oxygen debt. Oh yeah, during the lactate portion, you're recycling lactic acid into the Cori cycle, but you're also recovering ATP via the ATP PCR system. If you remember that system, like the creatine donates the phosphate and recover ATP, so you're replenishing your ATP stores in that lactate portion. Let's see what else. Now we're jumping right to muscles. Okay.